Imagine you're getting out of bed. The sun's rising. You head down to have breakfast when calls start pouring in. Reporters calling every number they can find. And they all want to know the same thing. Your palms start to sweat. When did you know there was a leak? Your heart quickens. Why didn't you report it sooner? Your stomach drops. How could you lose financial records for 20 million clients? That's what happened a few weeks ago to 20 senior executives in 3 financial groups. They resigned shortly thereafter. What I'm going to share in this webinar has the power to change every aspect of your life. So it's very important that you cut all other distractions. Sign out of your social media accounts, stop checking your email, put your phone in another room, because I want you to focus 100% of your attention on this presentation, okay? I've got 3 rules before we begin. Rule 1, we're going to have fun. Is it all right if we have fun? Good. Rule 2, I promise to give you 110%. Is it okay if I give you 110%? Great. Rule 3, this is going to be an interactive session. That means the more you give to me, the more feedback I get, the more I give to you. Is that fair? Excellent. Then the bonus rule 4 is you'll take action. You won't listen and leave. You'll decide and do. You know, success comes down to taking action, right? Great. At the end of this webinar, you will know how to develop software up to 24 times faster without sacrificing application security. You will learn how to save thousands in quality assurance and customer support costs. And you will have the tools you need to act on key application security challenges. Remember that financial data breach I mentioned earlier? It turned out a technician was stealing financial data from internal business apps. They were selling it on the dark web for 22 months before the breach became public. When news of the scale of the leaks became public, customers flooded the offices of those financial groups to cancel their cards. Call centers and websites crashed because of the upsurge in traffic. Within 3 days, almost 3 million people succeeded in canceling their cards. Imagine if developers had recognized the defects that allowed access to financial data without authorization. What if they fixed it before data started leaking from their applications? Do you think they could have avoided a disaster of this size? My name is David McHale, and I'll be your instructor today. So what makes me an expert on this topic? I didn't start out in security. For many years, I worked as a software and infrastructure engineer. I worked with clients all over the world, but there was one client in particular that led me to a career in security. Not the kind of client you'd expect at all, mind you. It was a small firm headquartered in the heart of Texas. They only had a handful of employees, and they were 100% on the cloud. One day, they decided to work with a third-party software company in Bulgaria. And for months, the relationship went off without a hitch until the Bulgarian software company, the development company, began using GitHub. They included access keys for my client's cloud account in a public repository. They didn't even realize there was a risk associated with doing that. And that exposed access to the firm's cloud account to malicious attackers. I remember that morning, and it wasn't so different from the story I told earlier. I'd woken up at 7 a.m., gone through my morning routine, had breakfast, and I was settling into work at around 8:08 a.m. when my phone started buzzing off the hook. Emails from the cloud provider, budget warnings, charge notifications as they hit billing thresholds. Do you catch my drift? I had no idea that the credentials were public and that attackers were exploiting them yet. All I knew was this client's cloud account had 12 small servers a few minutes ago, and now it had 1,600 of the beefiest servers the cloud provider had to offer in a matter of minutes. I rushed to find what was creating these servers and cut them off at the knees at 8:17 a.m. I tore through the server listings for all 24 regions in EC2. In every one, attackers had created servers. By 8:38 a.m., I'd removed all the malicious servers, but I discovered the attackers had deleted all the original servers that my client had created to make room for more of their own servers. Luckily, they took daily backups, so I was able to restore them from that morning's backups. Once chaos was over, I figured out the servers were mining cryptocurrency. They cost $24,000 in usage fees. Worse, they cost the firm more than that in lost data and revenue from their servers being down, especially with big marketing campaigns running at the time. And things could have turned out much worse if they hadn't had working backups in place, or if they hadn't had someone able to perform that incident response and fast. Are light bulbs going off in your brain? I ran the math at the time, and the attackers made about $700 from the attack. $24,000, $700, senseless in the face of how much damage it caused. Since then, I've helped develop cybersecurity shops in a half dozen industries. I've authored 4 books sharing how companies can tie security into their processes. I performed dark web investigations for over 1,300 organizations worldwide in 2020 and led a global team of bug hunters to test application and infrastructure security for companies like Hyatt, Zelle, Logitech, Shopify, and Verizon. I've managed successful security automation and vulnerability management programs, and I built infrastructure that now powers phishing simulation and application security training programs at hundreds of organizations worldwide. More than that, though, I've seen the damage software defects in your business applications can cause firsthand, like exposed access keys. Every day, more than 5,000 applications become vulnerable. How? Private keys, database connection strings, certificates, and passwords leak. That's on GitHub repositories alone, putting applications at risk. Each of them could have avoided having their leaked data used against them. And application security training provides us with a unique opportunity to enable our teams to find and fix common software defects before they waste money and create risk for your organization. You see how this could benefit you and your team? Kent Beck, author of Extreme Programming Explained, put it best. He said most defects end up costing more than it would have cost to prevent them. Defects are expensive when they occur. You have the direct costs of fixing the defects, sure. Then you have indirect costs, damaged relationships, lost business, lost development time. And that's when you find out about them. Your team and customers aren't the only ones finding defects. I went into the web application firewall for our corporate domain, hailbytes.com, and I went over the logs for every single day for the past month. I looked at what services were being hit. And this isn't from dozens of hours of crack investigation work. This is about 25 minutes of investigation work. And you know what I found? I found 20 SQL injection attack attempts a day on average. I found 181 scans that look for vulnerabilities per day on average. Folks who are chucking our domain into commercial vulnerability scanners. Some even identified themselves as Nessus or Nikto scanners. There are a couple of commercial security scanners that are being used as well. We had 6 attempts at exploits for WordPress, and we're still seeing probes for shell shock. Yeah, that's about a 6-year-old vulnerability. 3 attacks per day on average for that. And this is not a unique experience. The most targeted among all these exploits were cross-site scripting attempts, even after I removed the hits from our regular internal scans. So you're getting attacked all the time. Software vulnerabilities are the way they get in your system in the end. So why not do something about it now? Why not fix the problem? And this is what we're here to talk about. The problem also is that we depend on software. We depend on applications. Business decisions tend to be data-driven. So applications run our business. For instance, if we're deciding whether we set up a new virtual workshop, we look at our sales and similar events last year, how many estimated people that will come this year, how many security professionals are seeking content in that particular area, and all this data is then used to make business decisions. our enterprise resource planning systems, plus whatever is being used as input to make those business decisions. Without reliable software, we can't make those decisions. One thing I always hear is, why don't we block all attachments? Great move. Problem is, how are we going to do business? I ran into a financial company that tried it about 3 years ago. They went through the usual cycle after a major security incident. They had an exploit that took down a large part of their infrastructure. After the incident is when people always start thinking about application security. They were working their way through the paranoia stage. It's not unusual after a large incident like this. And they did not allow attachments in and out of their network. So I got an interesting question from their training manager one day. And they had their laptop right there. Hey, can you help me with my personal laptop? And remember, they could no longer receive attachments at work. So they were using their personal laptop and email for more and more business correspondence, including FedEx shipping receipts from folks like us who are sending books. So they are always receiving FedEx tracking information for books. So what did they do? They opened a malicious attachment that claimed to be a FedEx attachment. Well, it did not have their tracking information, but it did encrypt their hard disk. So you can't get rid of these applications. You can't shield your enterprise from these applications by cutting them out entirely. And it's not that simple stuff that you have to worry about, losing data or it getting stolen as much. Dealing with the fallout of that security incident can run you $150 per record. Sounds about right, given all the time that you spend in response. It's not about the $10 per user that you have to pay for credit reports and such. The FBI estimated, in fact, 500 million financial records stolen last year. Everybody's financial record got stolen at some point last year at once, basically. That's a sad truth about that. And the problem attackers run into here is that they no longer get as much money for every social security number, every credit card number that they steal. So there's a depression in the market for this stolen information. And if you think about it, it's often not stolen technically so much as it's copied. Whenever you copy information, you're reducing that scarcity. And with that, you reduce the value of it. Many organized criminal groups are adapting. So instead of actually stealing or copying information, their goal is to remove your access to the information. And the instance of CryptoLocker I mentioned a minute ago, according to the FBI, hackers make $2,000 to $10,000 per attack. Of course, that depends on if it's an enterprise or an individual. And yes, a lot of individuals actually will pay that sum. We were looking last year at some of these ransomware attacks, and we're seeing new laundering techniques as well, used to make it more difficult to analyze the Bitcoin addresses that are involved. New tumbling services, customized Bitcoin addresses for each particular target, and we're seeing new approaches in how attackers are manipulating data in enterprise resource planning systems, for example, tricking a victim into producing expensive parts for certain projects, which then gives the attacker an advantage in the bidding process for those projects. And again, this gets us back to how we make software-enabled business decisions. It provides us with all the input that we need to make those decisions. So it's important in application security to consider the scope of the program. Think about the ways you'll need to look at the components that make up software in your business. Most people think of application security as a process where you apply a best practices tool to the software you write yourself and call it a day. It's not only software we write ourselves. It's also the software from key vendors that we depend on every day. It also affects software that you buy off the shelf. And you have the software that you build your software on top of. If you write software in-house, you rarely write software from scratch. Scratch in the sense where you're writing your own compiler. You buy compilers, you buy libraries, you buy an awful lot of bits and pieces. Or you use open source bits and pieces. And then the software that you write, if you're writing software like most, is the duct tape that ties all those pieces together. That's the internal part. Now, you want to vet that software before you use it. So where do you start with vetting of the software that you buy. A big part of this is getting a good risk assessment. GitHub is the world's largest platform for open source software, and they set out to figure out how vulnerabilities in software on GitHub began. And they found malicious contributors create 17% of all vulnerabilities in software on their platform, and the other 83% was well-intentioned human error. You cannot create secure software. That sounds a little bit fatalistic. Okay, are you telling us we're going to fail more? Our software is going to be more insecure? I'm telling you that it's very easy to create vulnerabilities if you don't recognize them. It's hard to tell when bad guys are creating vulnerabilities right in front of you if you don't recognize them, and right in front of the maintainers of the third-party packages you use every day. You have to arrive at a good estimate for what risk you expose your enterprise by writing software or by buying certain software. And then in the end, it's a business decision. Which risks do you want to take? Is the gain for the business from the software you're writing worth the risk of someone manipulating that data? To know this, you have to figure out what risk you're actually exposing yourself to with that software. And that analysis usually starts with the vendor. One of the best tricks here you can use with a vendor is asking them as part of your buying process. And in particular, for custom software you buy from a vendor, you can ask them to produce something like a pen test report. You'd also ask them to produce a test report as evidence they ran it through some kind of static code analysis. And I call this a trick because, of course, they'll almost always come back with a clean report. But the trick is that you actually make them run the test. If you don't ask for the report, they may never run the test. And of course, the first time they run the test, it comes back with some defects, and they'll usually fix it and then show you the fixed report. So in the end, you wind up with better quality software. And then you have this report to see how thorough their test was. So consider doing this early on, like I said, during the beginning stages of the buying process. And that's when you can usually make the biggest difference here. Very, very important. Very important. Also, enumerate your software dependencies. You had so many vulnerabilities in various libraries last year. One of the nightmares of vulnerabilities is the event stream package on NPM. It's included in over 2 million software projects, and anyone using it was allowing the attacker to mine for Bitcoin in their applications. Any instance of that application that was started that was using the event stream package from NPM. The next question you ask yourself is, are we vulnerable? And you don't know that if you don't enumerate these dependencies. Starting early on, doing these inventory tasks is critical. I spoke to a friend recently who works for a large enterprise, and they contracted a pen test for their internal network. And you know what they found? A total of 30,000 vulnerable applications in the enterprise. Well, that's a ridiculous number. In hindsight, you'll never even be able to figure out what many of those applications do. Most of them you could turn off. In the worst case, with no software inventory, you could turn them off and see who complains. But of course, that's not always workable and definitely not the proper way of doing it. You want to have that software inventory. Why do we care about which software we're actually using? Well, it saves you money. That's the selling point right there. It's not about purchasing higher quality software. Of course, that will follow if you do this, but it will save you money to go through an audit, because if you have to go through 30,000 applications and figure out what's obsolete, what's not in use in that particular library, you'll be able to save time, cut risk, and save money, rather than carrying the risk of unused software, paying for it potentially, and dealing with an actual incident after it happens. An example here, a lot of people use Magento to serve as a basis for their e-commerce hardware. And if you're using a free open source e-commerce software, often you're not going to use the software as is. What you're going to do is you're going to change it to fit your products, add your skins, all that, which makes things like Magento difficult to patch. Is this still off-the-shelf software? Is this a component that you use? You can make a case for both with Magento. But once you start writing your own internal software, you have to deal with components. Not only vetting these components, you also have to reduce the number of components that you will have to deal with. In any case, we must not leave our applications vulnerable and unprotected. So how do you get buy-in from your team for helping to improve the secure software development lifecycle? Framing security problems like functional defects in software can be effective. That makes it easier for developers to understand the problem and to integrate them into your process and train them how to fix defects. In the end, what they have to do is very different for security compared to a regular functional defect. Developers often don't see security as a part of their problem set. So once you declare security problems are software defects, it helps to shift the perception. So it becomes the best interest of the developer to reduce them, because a developer is more willing to fix software bugs to produce working software. What's interesting about software development is the cost of those software defects rises as soon as you introduce it. So why does cost increase in this manner? I mean, let's consider the following points. It is much easier to detect issues in code when developers are still writing the code, when the code is still fresh in the mind. It can be trivial to fix even complex problems. As time passes and the code moves to later stages, developers need to remember everything and hunt down issues before they can fix them. If an automated system finds issues in code when the developers are still writing the code, they are much more amenable to include the fix for the same reason. Once the software is in the testing phase, reproducing the defects in a developer's local environment presents another time-consuming task. It's easy to catch something that's broken or doesn't meet requirements. It's difficult to uncover defects which are more fundamental. Think about memory leaks, buffer overflows, and race conditions. If these issues escape the coding phase, they generally don't present themselves until in the production phase, unfortunately. After the software deploys out in the field, it's not only difficult to find defects, it's risky as well. You risk problems impacting live users. Ensuring availability of your service is business critical. These effects compound, and the cost is up to 24 times more than if we catch those defects early on. So what can we do to mitigate the cost and risk here? It's valuable to put in place processes which help developers detect early, detect often. The development workflow should ensure that we detect defects as early as possible when code is being written by the developer, when it hits a code review stage before merging to the main development branch. Processes like continuous integration help keep changes to the code small and manageable, so it's easier to detect issues. Tracking code coverage and ensuring a certain level of testing is also helpful. Plus, it helps guide efforts to fix defects early on. Static analysis can help keep code clean. It works by searching source code for hundreds of anti-patterns and security vulnerabilities. Invest time in training developers themselves to recognize common types of security vulnerabilities. Your processes and conventions should focus on shifting defect detection left. That means as early in the workflow and as close to the developer's coding environment as possible. The same compounding effects, which inflate the negative impacts of late defect detection, they can work in your favor for increasing software quality and resilience. Jeff Sutherland often tells a great story about this mid-sized technology company in California. They made some of the first of what were then called personal digital assistants, or PDAs. Now we call them cell phones. They tracked everything they did. One of the many things they measured was how long it took to fix a bug. That is, how much time it took a software developer to fix a problem they'd introduced into the system. The computer tracked this automatically each time. So let's say that one day, when the testers tried to integrate Matt's code into the rest of the system, they detected a bug. Matt, like most software developers, wouldn't want to go back and fix that code right away. Instead, he'd vow to get to it later. First, he'd write new code. At most companies, this kind of testing doesn't even happen on the same day. It could be weeks or months before all the tests run, and only then are the problems discovered. But this company performed daily automated tests of all their code. So they knew right away when there was a problem. They looked at the mats across the entire company, hundreds of developers, and they decided to analyze how long it took to fix a bug if they did it right away versus if they tried to fix it a few weeks later. Now, remember, software can be a pretty complicated and involved thing. So what do you think was the difference? It took 24 times longer. If you fix a bug on the day you create the bug, it would take an hour to fix. 3 weeks later, it would take 24 hours. It didn't even matter if the bug was big or small, complicated or simple, that multiplier remained the same. It always took 24 times longer 3 weeks later. Every software developer in the company was soon required to test and fix their code on the same day. The human mind has limits. We can only remember so many things. We can only concentrate on one thing at a time. This tendency for the process of fixing things to get harder as more time elapses, it represents a similar limitation. When you're working on a project, there's a whole mind space that you create around it. You know all the different reasons why something is being done. You're holding a pretty complicated construct in your head. Recreating that construct a week later is hard. You have to remember all the factors that you were considering when you made that choice. You have to recreate the thought process that led you to that decision. You have to become your past self again, put yourself back inside a mind that no longer exists. Doing that takes time, a long time, 24 times as long as it would take if you had fixed the problem when you first discovered it. So we know unsafe coding practices result in costly vulnerabilities in application software. We know that can lead to the theft of sensitive data. We know secure coding awareness must work into operations and development. Application developers should complete secure coding training regardless of programming language. A critical first step to develop a secure application is an effective training plan, one that allows developers to learn important secure coding principles in practice. So what are some of the specific principles that developers should be familiar with? Developers should be comfortable with concepts like input validation, output encoding, and authentication, and how to handle password management, including secure handling of credentials. They should be able to understand session management and access control, and they need to understand cryptographic practices like hashing. Plus, understand how to handle and log errors. They should be comfortable with configuring systems securely and securing databases. And they should also be capable of secure file management and memory management. Improving your application security takes time and hard work, but the payoff is huge. Fewer emergency production patches, faster development, happier customers. So what should your next step be? If you're serious about improving application security, you can start training your team with everything that I just mentioned in the next 15 minutes. At HailBytes, we offer a unique take on application security training. We work with Amazon Web Services, so you can launch your own security training range in minutes. You can visit yoursecurity.sherpa.com now to test drive 2 weeks free training for your team. That's $470 worth of application training services at zero cost to you. And you'll be able to continue training with us for as little as 49 cents an hour. Plus, we have a 365-day money-back guarantee. That means it's risk-free when you decide to continue training with us after the free trial. No technical or human resource headaches, no hassle, so you can get the best education for your team. You can start your trial at yoursecurity.sherpa.com right now to save money and cut risk in your org. And if you're one of the first 10 attendees to sign up for the free trial today, I'll also send you our proactive controls and secure coding process guidebooks as a thank you. That's yoursecurity.sherpa.com. You'll be up and running in under 17 minutes. Good luck cutting the cost of software bugs in your org. And remember, knowledge isn't power until you apply it.